Hi, this is a solution for the problem in which a first aid kit is thrown by one hiker up to another hiker. And the question is, how high up is the second hiker from the first hiker? And the information given is that the first aid kit is pitched at 11.3 meters per second at a 65-degree angle. And when it reaches the second hiker, it's moving horizontally. So to solve that problem, I'm going to switch screens here and do this on a piece of paper. So you probably recognize these as the equations of motion for kinematics. And I've put subscripts on these because you would only use this first equation for the horizontal portion of motion and these three equations for the vertical portion of the motion. So I'm going to start with a little diagram. So we've got this first aid kit, and it's pitched at a speed of 11.3 meters per second at a 65-degree angle. And so it does something like this, and it reaches the second hiker at this point when it's moving horizontally. So its final vertical velocity has to be 0. So how can we figure out what this change in height is, delta y? Well, the most common error that people make when they're starting out with projectile motion problems is to confuse x and y directions. Since these two motions, the vertical and the horizontal, are totally independent, you can't combine variables in one dimension with variables in the other. So I think it's a good way to start a problem like this, just making sure that you get your givens in the proper place. So we've got x givens and y givens. So what have we got here? Well, in the y direction for any projectile motion problem, you always have this. You always have that the acceleration is negative 9.8 meters per second squared, because all projectiles are free falling. We also know that since at the end of the problem it's moving horizontally, your final velocity is 0. And what we're trying to find is the delta y. We could use this equation here if we knew the time that was in the air and the vertical velocity initially, or we could use this one if we knew just the vertical velocity initially. So let's do it the easier way and find this delta y with this last equation. Now, to get that initial vertical velocity, what we're going to do is break this overall velocity into two vectors. We have a vx here, the horizontal velocity, at the instant it's launched. That doesn't change. And the initial vertical velocity at launch, that will change. We could figure out the vx, but this is a fairly simple projectile motion problem, and we don't even have to worry about the x direction. So we're just going to figure out this vertical velocity initially. The way to do that is that initial vertical velocity is the overall velocity, 11.3 meters per second, times the sine of 65 degrees. And that is 10.2 meters per second. Okay, so that's something we can put in our table here. And at this point, we have everything we need to find this change in vertical displacement, delta y. So let's use that equation, bring this down here. And I'm going to solve for delta y. With that equation, delta y equals final velocity squared minus initial velocity squared divided by 2 times the acceleration. And the final velocity, we know that's just 0. So 0 minus 10.2 squared all over 2 times negative 9.8. And let's see what we get here. Okay, here we go. So we've got 10.2 squared divided by 2 divided by 9.8. I canceled the negatives out already. Equals 5.31. 5.31 meters per second. And that's it.